Hi everyone. For those that haven't seen me at any of the other events, my name's Elise. I'm one of the co-founders for Our Ladies Perth. A PhD student. I'm almost at the end, but I've been almost at the end for about 6 months now. So it's like the right at the end. And I'm also a data officer for one of the cohorts of the rain study at UWA. So I do a lot of data cleaning and stuff as well as my studies. So for today, we're just basically doing an introduction to data visualizations. We'll be continuing on in the tidyverse, so using ggplot2. And you can download the document from that webpage as well. So everything for today was coded in R Markdown, which is another tidyverse package, and then it's knitted together with knitr. And this is actually easily done through the RStudio console and what will be discussed at the next workshop. So if you want to learn how to do this, you can make really cool HTML links, you can do slides and stuff like that through this program. So there's some more information on that cheat sheet link as well. So far we've introduced you to importing, doing some tidying, doing some sort of summarization. So this was spoke about at the last workshop. And now we're moving on to the visualization part. So with visualizations, you can think of it, I think it's actually probably the most important part of statistical analysis is how to present your data, but it's not actually presenting it to your audience in a meaningful way at the end either. It's even just during your actual data cleaning itself and also exploration of the data to see what the distributions are like. So they're useful for all sorts of tactics. So actually with my data cleaning job, I use histograms and lots of scatter plots and stuff on the regular just to see where the outliers are without having to actually look at the specific data, because sometimes it's quite a bit more obvious. So why bother with R if you can do graphics in other programs? Well, for example, this is just a simple plot from SPSS, and you can see, I mean, you can make some adjustments to it, but they are pretty basic with a lot of these other programs. So that's why R really has become very popular for visualization. So this is actually code that I've hidden from this graph, but if you want it, I can send it to you. Basically, these are an example basically of what you can do in R. So you've got 3D visualizations of different distributions. I think this is in the ggplot2 book, this code. You can also put spatial analyses on maps. So this is just one area, but you can actually get a world map if you're looking at the distribution of some disease, like prevalence, for example. So that is also something that it can be used for. This is actually from one of my studies I'm publishing at the moment. So it actually took me 2 days to figure out how to get those numbers right in the right spot. But you can actually tweak it in such a way that you can, you can adjust the colors as well. This, I wanted to look at the different responses. This was actually by age category, what percentage of people were playing games on the computers, so in an older population. So that was just one part of the analysis. And then also you can overlay different types of graphs. So this is a box plot with scatters over the top, and the scatters are jittered. So this could actually be quite useful because box plots, although they're good for looking at distributions, sometimes it can be misleading if you've only got a few observations in that group, for example. So here you can just see how it is, I guess the data is in general. So that's, I guess, where the power of it is. We will be getting to this point today, so you'll be able to do some overlaying. But basically the point of today is just to introduce you to the language so that you can start looking into it a bit further. So as I mentioned, we'll be using ggplot2, and it is based on this grammar of graphics, which was kind of what Hadley Wickham has used to create this whole program. So there's several R packages that can be used for data visualizations in R, but the reason why we use ggplot2 is because of this sort of like grammar that it follows. So it can also be piped, so your analyses can be piped straight from your data cleaning process if you're using the tidyverse, which Pallavi mentioned in the last workshop as well. So if you think of a grammar of a language, it defines rules of structuring words and phrases into meaningful expressions. So for ggplot2, it implements its own grammar which is a consistent language for describing and building these visualizations. So the good thing about having this consistency is that you can actually learn it a lot faster, because a lot of the options are quite similar in the different types of programs that it is running in the background. So you'll see examples of this today. One thing to remember though is, even though grammar is consistent, you still need to be clever about which types of plots you choose. So you can't just chuck it into a certain plot and it's the wrong thing for your analysis. Okay, so an easy analogy, which was taken from one of Wickham's articles, to the English language, is good grammar is just the first step in creating a good sentence. Okay, so this gives you the tools, and then you can go away and you can actually put that work together. So you can learn more about this grammar graphics from this link as well, which I've included in there. But today we'll just be going through the basics, and you can already see down here some of the basics we'll be going through. So I'll try to give you a few of the more common graphing options in ggplot2, and then at the end there's also a cookbook to our link that you can use to look up some more options. Okay, so with the base ggplot function, it has this general form. So when you load the package, so as we've been doing, we've been installing all of the tidyverse, and then every time you go into a session, you have to load the particular package. So here it would be ggplot2. From there, whenever you call a ggplot object, it's always ggplot, open bracket, whatever the data frame is called. You have a comma, and then you put AES, which is aesthetic, and then you put open bracket, and you have your options in here, and we'll go through some of those options as well. So it always has this base, and then from there you add what layers. So if you actually ran just ggplot, whatever the data was called, and then put x is equal to this variable, y is equal to this variable, and just run it, it will come through blank. So you do need to tell ggplot what layers you want to add to your graph, even though you put the data in there. So for these examples today, we'll be talking about data and aesthetic mappings, geometric objects, which are called geoms in ggplot, and also facet specifications. So here's some of the geoms that you might find useful when you're doing some of your plotting. We'll go through most of these today. So if you're doing scatter plots or points on a plot, you go geom underscore point. Then you have lines for the line graph. So if you're doing time series, etc. Box plot, histogram, you've got density, and a violin, which is like an adjustment of the box plot to show you what the distribution of the data is. So there's some of the examples from today as well. But the good thing is, all you need is at least one geom, but there's no upper limit. So you can actually do whatever specifications that you want for your plots. And they're easy just to add. So you literally just put the options in for the beginning base function for ggplot. Then you add whatever geoms that you want just by having a plus symbol, and then you add each individual one. So I'll show you that a bit later. If you want to call in this function, you'll actually get a full list of the geoms that are available as well. So the next thing in general to learn is this idea of aesthetics. So they're a part of the ggplot sort of grammar, and they change depending on the chosen geom. So certain geoms won't use certain aesthetics. But some of these examples include, say, x equals in those aesthetic options, which is just for the x-axis, y equals, which will just be the y-axis, colour. Because Hadley was from New Zealand, he's actually put both the Australian English and the American English version of those spellings in, but you can just go colour equals and then what you actually want to outline those objects in. Fill will actually fill the objects with different colours according to the factors. Importantly for these two, you need to make sure your variables are set as factors, otherwise it won't work correctly, but we can have a go with that later. Alpha will actually change the transparency of your objects. So this, I'll give an example of a bit later on when we do layering. So you have a box plot and you might want to layer points on top of it, but you don't want them to be as strong. So you put them as like a 50% transparency, for example. And there's also line type as well. So you can change from like a dash or a solid line, you can change thickness and you can change the colors and stuff like that. So I'll have an example of that too. Some final comments in terms of formatting as well. You need to make sure for graphing in ggplot2 that your data is of the class data.frame. So if you have a matrix, you need to first convert it to a data frame. So you can do that with an as.data.frame argument, which you can look up on Google and stuff as well, with all of those other learning resources we discussed in the first workshop. Also, you can, one of the, I guess, unique aspects of using ggplot is you're not limited to just one data frame. You can actually have multiple data frames that are all in the same sort of plot. Okay, so you can choose to either follow along in R if you like from now, if you wanted to open it up and just follow what I've got on the board, or you can just have a listen and then we can play with this a bit later. It's up to you. But basically, the good thing with this R Markdown file is you can actually put some code chunks in and then what the code actually looks like, so you guys can actually see how it's playing out in the program. One thing we haven't really spoken about is, I guess, good formatting in R scripts. So one thing that I tend to do is I put notes everywhere. So if you wanted to leave a note in your code in RStudio, all you have to do is just put a hash, and then you can write your sentences after it. Sorry. So that's actually what I've done throughout, so you can see how it might be structured. So the first thing you would do before you begin, you would just call the library ggplot2. So if you haven't installed it onto your computer before, you need to do install.packages first with the ggplot2 in the brackets. And for today, I've just chosen to use a very simple data set that's easily available in your environment. So it's called empty cars. And what I've done is I've just assigned it to an object X, just to make it really easy to call while I'm going through. So empty cars is just a collection of different measurements from these different models of cars. So what I've done is I've actually assigned it to the object X, and then I've just run X, and then it will bring up the whole data frame as such. If you need me to stop as well, just put your hand up and I'll run over. Okay, so we've got our data frame. One of the first things I do when I have a new data frame loaded in, if I'm reading it in, especially from like a CSV file, is to make sure it's been read in correctly. So here you just do like the structure function, which is good because it'll give you the first lot of observations from every variable, and then what each variable name is. So if you wanted to call these individual variables, you would put X, the $sign, and then whatever the variable was called, and you would be able to use that variable as well. Now we can see here it's just loaded a whole bunch of numerical data. You can see for cylinder, for example, we've got 6, 4, and 8, so this should be a factor. Usually you would do some data cleaning at this stage to convert your necessary variables to factors and such, but what I've actually done is I've actually done that in the plotting, so you can see what that looks like as well, because we did the data cleaning last week. So if you have any questions about that, feel free to stop me too. Okay, so this is what the base function would look like. So for here, I'm just looking at ggplot.x, because that's what I've called my data frame. And then the aesthetic, all I want to look at is horsepower. So I just put HP in. And then I've just gone plus, and you can go to, once you've done that plus symbol, you can go to another line as well, and it will automatically indent that. And I've just called a geom histogram. And you don't have to put anything else in there at this stage. You can just go geom histogram and it will load this up. Obviously, we can do much better with the plot, but we're going to continue and build on that as we go through. Now, maybe you want to actually look at the distribution a bit differently. So density. So this just smooths out the distribution of that same data that we had just up here. Same sort of base function, but this time you've just put plus geom density, for example. If we keep going on, what I did for the next one is actually added a factor in there. So this was whether the engine, so the density of horsepower according to the outline, which is the color aesthetic. You have to make sure it's a factor, but whether it was automatic or manual. And you can see that the densities are slightly different for horsepower there as well. But again, this is still quite a basic sort of graph, so you might want to change some of the options on there as well, which we'll be getting to now. Is there any questions there? No? Okay, so scatter plots, bless you. Now we're going to start using a few different options. So here I've called the base ggplot function. I've then got aesthetics. I've called miles per gallon on the x-axis. On the y-axis, we've got displacement. And then the colouring was by cylinder this time as well. And then we've just gone plus, and then the next line just called geom point. So this is like the basic sort of scatter plot that you might start with before you start adding some options. Okay, so from there, we might want to change the title, add some units. So here we've got miles per gallon, displacement by cubic inches. We've put a title on there as well. So we're colouring by the car cylinders. But, you know, you don't want to just stop there either. So these options as well, so that these two are quite easy to remember. So you've just got X lab, open bracket, and then you put the label in there. Also Y lab. There's different ways of doing this as well, so you can actually look that up. But these options are consistent throughout ggplot. You can also add a title just using this function as well. And there's different options within those additions. So these when you start adding, so you put plus and then you put the next option, they're actually layers, so that you can alter each individual layer separate, independent of the others as well. Okay, so now I wanted to update my legend because it was just a bit basic here. We've called as factor cylinder, but it doesn't look as pretty as actually adding a title. So to do that, we just add one more option. So again, it's that idea of layering. So you've got all your other options, and then you go plus, and you add the next option here. The good thing about this is as you're going through and developing your plots, so as I said, that one right at the start took me like about a day and a half to figure out how to get the numbers in the right place. But you can keep just running these functions and go, okay, I just need to adjust this part, and you can really get quite specific with them. So we're going to go even further. I really like using this theme. Everyone has their own options, but you don't have to be constrained to the just grey sort of background theme either. So this one's theme black and white. So again, it's just another layer. And it just looks a bit nicer for publications. But there's other options as well. So you can get completely blank options where you get rid of the axes and then you can manually add them on. You can even change the labels on the axes, like the different ticks as well. So there is quite a bit that you can do with these. Okay. Lastly, well, I've got two more things here. So we're adding a regression line. You can do this again, just adding one more geom. So this is actually geom smooth, which has a lot of different options. Here I've just done a basic sort of regression, coloured it purple because it's the R ladies colour. And here with SE equals false, I've just gotten rid of the confidence intervals, but you can add them in as well. Okay. Now, if you wanted to do, you could do these regressions as well per the different cylinders, and that would probably be easily done through a facet, which is also going to be introduced in one of the other sections. Yeah, so again, you've got the regression. I didn't put the regression on here, but you can see with the facet wrap, you just add another option. I've changed the theme because I wanted to move the legend to, so if I ran this without this theme option here that I added as a layer, what would happen is this actually ends up on the outside. So you can actually move these around your plot as well. So for example, with my black and white plot I had earlier, maybe you would want to put your legend in the big blank space instead of having it on the side, just to make your plots look a bit cleaner. Okay, so then that just gives you the different sort of displacement by a car cylinder. Right, so moving on to box plots. So now we're starting to put some different aesthetics in there. So for here, we've got X, Y, and then just color as factor. Again, we've got the automatic transmission, or manual. This is to do with a quarter mile in how many seconds the car ran. And this is the shape of the engine. So at the moment, you can see it doesn't really give you much information from that plot. So again, we're going to work and add some of those layers. Now, I've skipped a few steps here, but I'll go through these options. But basically, I've just done everything that we did on the above options. Used a different theme. So this one's actually got thicker background lines rather than the black and white one, which has kind of the grayscale lines in the background. I've added all the different labels. And now I've used the option fill. So the color option does the outline, the fill does the actual inside of the objects. Then added labels. So we've got the title, we've also got the legend that's done, and then I added manually the labels for the x-axis, because obviously with the box plot you've got actual variables there. Okay. So next I've actually done the layering with the points. So here we've just added, so you can see here we've got the box plot argument, and then I've added a geo and point argument. You probably don't need to add those aesthetics, it's a bit redundant, but the position jitter will actually give you this kind of spread of the points when they're in the same position, so you can see if there's multiple points there. And this alpha option was what I introduced at the start, so going alpha 0.5 will just give you 50% transparency on those. So they're on the grayscale, but you can change the color of them as well. And that, I don't know, you can just jazz up the plot a little bit. You can also do these jitters. So if these box plots were empty, for example, but you wanted the jitters different colors according to the factors, you could do that as well. So go the opposite way. I've done that for another publication, which I haven't got here. So again, these are all the same options I had before. All I did from this box plot was change the theme from this line draw to black and white, and then add that one line of code, and it changes automatically what that figure starts to look like. So in some cases, especially if you've got, let's say, continents or something, and you're looking at the different box plots, you might want to actually put the box plot on a horizontal axis rather than a vertical. So you can add one option that's just chord flip, and it moves everything onto the other axis for you. So that is something that you can also add as well. So here I removed the alpha, so you can see that they're the solid black dots, and everything else is basically the same there. Okay, so that was layering plots, but what if you had multiple plots that you wanted to put into one figure? So this happens often if you've got some publication that's charging per figure. Maybe you want to put 4 different figures in to one, so you only have to pay one fee, for example. So here what I've done is I've just randomly chosen 4 of the plots that I just showed you. So the options are basically the same, but I've called them to objects now. So rather than just running the ggplot itself, I call it to an object. So I've just got A, B, C, D, just to keep it nice and easy. You can call it whatever you want. So same theory as if you're calling something to a data frame name, you're just calling it something so you can actually access it. Now we run require, which will just load this grid extra package into your environment if you require it. And then you run this function here, so grid arrange A, B, C, D, and then the number of columns too. And what it will do is actually put all those together. Now, when you actually run this yourself and save the PDF, so it doesn't look as great here, but when you actually save the PDF file, which I should be able to show you in a second, it actually spreads out quite nicely. So that's the next one I have to show you. So you can also export your plots that you do in ggplot using this gg save option, and you can save them as PNG files or PDF files. If you look up, if you go !gg save in the console, you'll be able to get the help information for that. But basically all you do, so again, here I just called that function grid arrange, but what I would do is assign that to an object. All those other objects, putting them together, making it its own object, and then you just save that to some file name, making sure you put what's format of file you're going to put in there, and then random size. Cool. So that was kind of a quick run through, and I guess the reason why I wanted to provide this document is so you can actually go back and work through these. But what we did that's a bit different today is I've just given you some options for different sort of data sets and maybe just some general questions. So you don't have to go through all of them, but it's just maybe just to give you an idea of what you should be playing with in the program. If you've got your own data, I would recommend using that if you want to experiment with some different plots. But these are just some other data sets that are commonly used when you're practicing, and you can call them straight from the environment, as we did right at the start with the miles per gallon, or this MT car, sorry, data set. So if you wanted to assign it to an object, for example, the iris, that you could just go X and then put iris data set to it. Okay, so you won't need internet access for that. Yeah, I think that's everything. So if for those that came a little bit late, you can just go to this webpage and you'll be able to download the slides onto your computer. And that is all for today. So if you have any questions, yeah, let me know.